Hi everybody, it's Phil again, and today I want to talk about using a list to improve our rock, paper, scissors, lizard, Spock program that we did in week 1 of the class. So let's think back to what we did. We had this game that had two helper functions. One was the name to number, which took a string and converted that to an int, and the second one was number to name, which took an int and converted it to a string. So let's take a look at my program here. Here's that first function, name to number, which takes in a string, which we call name here, and then uses a bunch of if and else if statements to figure out and convert that to a number. Then we have number to name, which takes in a number and uses if and else if statements to convert that to a string. So what I want to do today is show you how instead of using these two helper functions, we can use a list. So if you think about how we implemented the game, we converted each of our different rock, paper, scissors, lizard, Spock into a number. So 0 was rock, Spock was 1, paper was 2, lizard was 3, and scissors was 4. If you think about lists are 0 index, which means the first item in that list is index 0. So I put a little list here, which is rock, Spock, paper, lizards, and scissors. And you can see rock would be index 0, or the same as. If name equals rock, then you're going to have a 0, and so on and so forth. Spock 1, paper 2, lizards 3, scissors 4. So let's go back to the program now and look at how we can convert that. So here in our RPSLS function, I have a list that I put in here where it's choices equals rock, Spock, paper, lizard, and scissors. So how do we convert the rest of this game? So what we're trying to get rid of number to name and name to number. So let's see where we implement that. So here we have name to number, player choice. And down here, we have number to name, computer number. So we're going to do computer choice first because this is actually easier. So if we think about it, all that does is takes a number and converts it to a string. So what we're going to do is we're going to take the name of our list, which is choices, and then we're going to access it at the index of the computer's random choice. So if we think about how we do list indexing, we do choices, and then we're going to access, it'll be either 0, 1, 2, 3, or 4 will be the computer number. Now let's think about how we're going to do this. For player number, we know what the string name is, but we need to get the index of our list. So let's go over to this Code Sculptor docs here and look at list. So here's all the operations that we have here. Let's go through this list and see what we have here. We have append, extend, insert, remove, pop. What's this? A sequence dot index. So let's check out what this is. So find item in sequence. Alright. This looks like this might be exactly what we need. So here we have a list and it says index.c output 2. So this format, this function here, gives us the index of the input. So let's see how that would work over back in our program here. So we want to use, so we have player choice. So remember it was the name of the list, which is choices, dot index. Alright, now let's run this and see what happens. So what we've done is we've actually, let me get rid. So here is those two functions. I'm going to comment them out for now. And let's run this program and see what happens. So you can see, player chooses rock, computer chooses lizard, player wins. So the the program still works just as we thought it would before. And now, I commented out all this. Let's get rid of all this. So now, this program works with just this one function because we have implemented this list. This is just one of the many, many ways I think that you can use list to your advantage. Hopefully this reiteration of this program is helpful. Thanks. See you next time.